Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the difference between force of gravitation and force of gravity. After that we will solve questions based upon acceleration due to gravity, and we will solve very important NEET and JEE questions also. Okay, so let's start the video with the very important topic, gravity. So here you can see very well, according to Newton's law of gravitation, gravitation is the force of attraction between two bodies. And remember that here, whenever we are using Newton's law of gravitation, these bodies can be spherical or the point masses. So in this situation, I have taken here 2 point masses m1, m2. Okay, so here what will happen that here both the masses will attract each other, no? Because gravitational force is always attractive. So force experienced by 1 due to the presence of 2, we can write here F12. Okay, similarly force experienced by 2 due to the presence of 1 is called what? F21. Okay, and in this context, this F12 and F21 is called force of gravitation or gravitational force, or in a simple language, just gravitation. Okay, now let's see. If one of the bodies is Earth, as I told you, Earth can be used in the context of any planet also. Okay, then gravitation is called gravity. Again I'm reading. If one of the bodies is Earth, then gravitation is called what? Gravity. Hence gravity is the force by which Earth attracts the body towards its center. Okay, so let's take here I have taken here the Earth, now anyhow the solid sphere, and just above the surface of the Earth I have taken one small mass m. Okay, now what will happen that here, now Earth will attract this mass small m towards its center. This is called what? This is called force of gravity, or simply we can tell just gravity. Is it? So this is the difference between a force of gravitation and force of gravity. In a simple language, gravitation and gravity. Is it? So if this topic is very clear, now we are going to move for the acceleration due to gravity. Acceleration, you can see acceleration due to gravity near Earth's surface in terms of mass m and radius capital R of the Earth. Okay, so now let's see. Let Earth is a uniform sphere of mass capital M and radius R. Here we are writing uniform sphere of mass capital M. We know very well the mass of the Earth. Do you think it is uniformly distributed? No, it is non-uniformly distributed. Even the Earth is not a perfect sphere also. But to keep the thing simple, we are considering like this, like a uniform sphere of mass m. Okay, and radius r. Even radius is also place to place it is changing, but in this situation we are considering very simple. Okay, now let's see. Acceleration due to gravity at a point is defined as the gravity experienced by unit mass at that point. Again I'm reading here, gravity experienced by unit mass at that point, because we know very well what is the gravity. Gravity is the force. Okay, so just kindly see here I have taken here the Earth. Okay, the radius of the Earth is r and its mass is how much here? M. Okay, now what is happening that here on the surface of the Earth I have taken some mass small m. Okay, now what will happen that here, as mass is small m, or what we can tell here, only we want to calculate the gravity, and this is our observation point. And when the observation point is outside the Earth, then the total mass of the Earth can be concentrated where? At the center of the Earth. So like here center is there, now here we can keep the mass of the Earth capital M. Okay, and here anyhow the mass of a particle. Now you can see very well this capital M and the small m. What is the distance between them? You know this is r, so this is also how much here? This is also r here. Okay, so now what will happen that here, this Earth will attract this mass small m towards the center. Now that means anyhow the force in which direction? Towards the center. So here I have drawn here the force. This force is called what here? Force of gravity or simple gravity. Is it? So now if I write here the mathematically, so mathematically I can tell here the gravity is given by force of gravity per unit mass. Okay, so 1 by m, and what is the force of gravity formula from Newton's law of gravitation? So we can tell here, see, G capital M first mass, small m second mass, by square of the distance between them. Is it? Now what are the things will cancel out? We can tell here this is small m and this is small m cancelled out, is it? That means we can write here this gravity value is given by gm by r square. What is coming here? G equal to gm by r square. And if in case, very very important, if in case mass of the planet, whenever we are comparing and mass of the planets are constant, then we can tell here the gravity is inversely proportional to r square. Now whenever we are doing the comparison of the planets and the mass of the planets are constant, then what we can tell, gravity is inversely proportional to r square. Remember that, very important. Okay, can you see here? Okay, now if we calculate this acceleration due to gravity value on the earth, okay, so if we talk about here the mass of the earth is how much here? Remember that here 5.97 into 10 to the power 24 kg. Sometimes approximately we tell 6 into 10 to the power 24 kg, also not a problem. And if I talk about here the radius of the earth, you have to remember that always like this, 6400 kilometer. But when you will simplify this, it will come 6.4 into 10 to the power 6 meter, is it? So as we know very well here, what we have got here, see, we know that the gravity value is gm by r square, is it? So now if I put here the values, okay, so what are the values are there? Let's take here, g value is 6.67 into 10 to the power minus 11. Mass of the earth, as I have told you, what is here? 5.97 into 10 to the power 24. By the radius, what is there? See, this is the radius. So 6.4 into 10 to the power 6 square, is it? And this thing is separate here, is it? This thing is separate. So what will happen that here, when you will simplify this, then this gravity will come approximately how much? 9.8 meter per second square. And again I am telling you, this is the very ideal situation in which we have taken earth is a perfect sphere and the mass distribution is uniform, but in a reality mass distribution is not uniform and even the earth is not a perfect sphere. Okay, so gravity value even on the surface of earth also it will change place to place. Okay, this is a very ideal value. G is 9.8 meter per second square. Okay, now after that here, if we talk on the moon, so remember that here for moon also, remember that the gravity value is given by here, we know that gravity on the moon. Now it will be here capital G, and here it will be mass of the moon by radius of the moon square, because the gravity on any planet, even moon is the satellite also, no? But this is bigger mass only, na? Heavy mass only, na? So there also we can tell force of gravity. Okay, so what will happen that here, like here it depends upon mass of earth and radius of earth. Here the gravity on the moon, it's a satellite, but it still depends upon the mass of the moon and the radius of the moon. Okay, so no need to remember these values and all for the moon and the mass of the moon and radius of the moon. Just remember that here this is the 1 by 6 of gm by r square, and again I'm telling you m is the mass of the earth and r is the radius of the earth. So from here remember that here, very very important, the gravity on the moon is 1 by 6th of the gravity on the earth here. Now G I am telling you for the earth here. Now, and again this earth can be used in context of any planet whenever it is required. Okay, great. Now let's see some important points is there. The first important point, see, mass of an object on moon is same as that on earth. So you can see very well here, mass on moon is equal to mass on earth, because mass means mass is the just the quantity of matter present in body. So mass you take anywhere, even moon, earth or any planet, the mass will always remain same, it will not change. But if we talk about here the weight, so see here, weight of an object on moon is 1 by 6th of its weight on earth. How can I tell like this? You can see from here, like see here. So if I write here, see, we know that, now see, gm is equal to, what is this? G by 6, is it? G by 6. If I multiply both the sides with mass of the object, so mgm is equal to mg by 6, is it? So hence I can write here weight on the moon is how much here? Weight on the earth by 6. As the gravity is decreased by 6 on the moon, weight will also decrease by 6, no? By a factor of 6, is it? Remember that here, no? Can you see here? And normally if we talk about here like our weight, so normally whenever we will tell our weight is how much here, we will tell our weight is, let's take for example 55 kg. But you will think this kg is the mass only. So normally we are telling our mass only, but in a general day-to-day language we used to tell here my weight is 55 kg. Normally what is the context? My mass is 55 kg. I just told for the general study purpose. Okay, great. Now let's see here students, here we are going to see acceleration due to gravity near Earth's surface in terms of density and radius. Before that we have seen mass and radius, but now we are going to see density and radius. Okay, now let's see. Let Earth is a uniform sphere of density rho and radius r. As I told you, this is just the ideal condition uniform, but it's not a uniform, it's a non-uniform. Okay, now see, mass of the Earth in terms of its density is given by, so here please, you know very well, density equal to mass by volume. So what is mass? Mass means density into volume. So I can write here mass means density into volume. So density, what is the volume? Perfect sphere means we can write here 4 by 3 pi r cube here. Okay, this is equation 1. Now, so now let's see. Acceleration due to gravity is given by, then we know very well here, see, as g equal to, I have told you, see, gm by r square. Okay, so if I take here this g by r square, na, what is the value of the m? Let's put here rho into 4 by 3 pi r cube. Is it? Now let's see what other things can be cancelled out here. You can see here from this r square, this r square will cancel out and only one power will be left here. So from here I can write here this gravity is given by, just see here, 4 by 3 pi rho gr. Very important formula, 4 by 3 pi rho gr. And remember that here whenever we are comparing the planets and their density is constant, density is same, so in this situation the gravity is directly proportional to r. Again I am telling you, if the mass is same, gravity is inversely proportional to r square, but if density is same, gravity is directly proportional to r. Okay, remember that here. Now when to use which formula, it depends upon the question. Okay, so let's see now. Now we are going to solve here the question. The question is, see, the mass of a planet is 1 by 10th that of the Earth and its diameter is half that of the Earth. The acceleration due to gravity on that planet is how much here? Okay, so first we'll note down the data. The data is what here? You can see very well here. The mass of the planet is 1 by 10th of the mass of the Earth. Let's take, I'm writing me instead of m, I have just put me to be very clear. Okay, and if we talk about here what is the diameter, what they're telling diameter? Diameter is half. Okay, so see, the diameter is half of the diameter of the Earth. Now, and now we have to calculate anyhow the gravity on the planet. So we know the formula. What is the formula? See here, g equal to the formula gm by r square. Okay, but you know very well here the radius is what? Half of the diameter, so d by 2 whole square. So from here I can write here g means 4 gm by d square. Okay, g equal to, in terms of diameter, what is there? 4 gm by d square. Even this thing they have asked in a JEE 2012 directly. Okay, after that let's see what other things are constant. This 4 is constant, g is constant, is it? So I can write here, see, g directly proportional to m by d square here. Is it? Now from here directly we can write here the formula, we'll make the formula. So if I take here the ratio, so gravity on the planet by gravity on the Earth, mass is directly proportional, so we can write here mp by me. Okay, after that the diameter is the inversely proportional, that means I can write here de by dp whole square here. Okay, so now let's see. From here when you will see mp by me, how much here? It will come here 1 by 10, is it? Into, after that what is de by dp? From here it will come here 2, so I will write here the 2 square. Now, so from here I can write here the gravity on the planet is here 4 by 10, that means 0.4, is it? 4 by 10 means 0.4 into gravity on the Earth. Gravity on the Earth, let's take here the kind of data is there, we have to take gravity on the Earth 9.8, even sometimes we have to take 10 also depending upon the situation. So when you will simplify this 0.4 into 9.8, it will come very easy, 3.92 meter per second square. So which option is correct here? The correct option is here, option D is the answer. If in case instead of gravity they asked weight and all that, so you know very well GP by GE equal to, this is coming 4 by 10. So see here please, just somewhat basic. So GP by GE is coming what here, 0.4. I will just multiply with the mass of the object. mgp by mge is equal to 0.4. So what is the weight? Will be what here, weight on earth into 0.4, is it? So sometimes if they are asking weight, you have to just change with how much factor gravity will change, and then in the same factor weight will also change, is it? Let's see here, is it? So now after that we'll go to the second last question. The question is what here, very basic question. The question is, see, if density of earth is increased 4 times and its radius becomes half of what it is, our weight will be how much here? Okay, so in this situation I am going to just write here the density of the earth is going to be increased by 4 times. So I am going to write here rho e dash is going to be how much here, 4 times rho e. Okay, and the radius is going to become what, half. So I can write here this re dash is going to be re by 2. Okay, so now you think which formula we have to use? We have to use the formula in terms of the density. So what is the formula? G equal to 4 by 3 pi rho gr. Okay, so after that what other things are constant? You can see 4 by 3 constant, pi constant, g constant. So from here I can tell g is directly proportional to rho into r, is it? So from here we will now make the formula. So formula will become here, see, the new value on the gravity, new value of the acceleration due to gravity, and the old value on the earth, ge dash by ge. So what this will become here, kindly see, directly proportional. So rho e dash by rho e into re dash by re. Now, so now the density, what is happening? See, the density is becoming 4 times. So from here rho e dash by rho e means 4 here, is it? And here re dash by re, how much here? 1 by 2. Now, so from here we can tell here this will become here 1 by 2. After that what I am going to do here, I am just going to multiply with the mass of the object. So mge dash by mge is equal to what is becoming here, we can tell 4 into 1 by 2, na? It will become here 2, is it? No, what, not 1 by 2. So this will be how much here, 2. So from here we can write here the new weight w dash is going to be twice of we. W dash how much here, twice of the w. That means the weight will become double. Why the weight has become double? Because the gravity has become double, because 4 into 1 by 2 is 2, not 1 by 2, is it? Can you see here? Okay, now after that we'll see here the last question, very important question. So in this question, let's see, a planet has double that mass of the earth, its average density is equal to that of the earth. Okay, an object weighing w on earth will weigh on that planet how much here, is it? So this question is somewhat little bit tricky, because mass also they are telling and density also they are telling, is it? So what we can write here, let's take, if we talk about here the mass, so you can see very well the planet has double the mass, so mp is equal to twice of me. And the density, what about the density? The density is equal, is it? So we can write here, see, the density on the planet and the density on the earth is water, it is constant only, is it? Or we can tell just rho, is it? And they are asking what is the weight on the planet and weight on the earth. What they are telling? Weight on the earth, they are telling here the w here, is it? See, w. Now how to approach this question? To approach this question, remember that here we will use the formula here. See, first let's see the density. What is the density? Density we know very well, the density equal to mass by volume, and here we can write here, see, 4 by 3 pi r cube, is it? In the question they did not mention about the radius and all that, na? So first let's see here the radius. So what radius will come here? We can write here r cube is given by, kindly see here the 3m, na? See, this 3 will go up, so 3m by 4 pi rho. Kindly see here the r cube is what here, 3m by 4 pi rho. Okay, so from here I can see what are the things are constant. You can see very well 3 is constant, density is same, pi is same, 4 is also same. So here we can tell here, see here, the r cube is directly proportional to m. What is coming? R cube is directly proportional to m. Okay. So from here we can write here, if I just calculate here the radius of the planet by radius of the earth cube is equal to how much here? Mass of the planet by mass of earth. Okay. So mass of the planet, what is given here? You can see very well that twice of the mass of the earth. So what is mp by me? It will come here 2. So from here I can write here, see, very easily. This rp by re is 2 power 1 by 3. What is rp by re? 2 power 1 by 3. Now we got the radius ratio. After that, now very easy. So here, as the gravity is given by G equal to the formula, use the formula 4 by 3 pi rho gr. Is it? What other things are constant? 4 by 3 constant, pi constant, rho constant, g constant. See, the rho is constant. Is it? So we can tell here this G is directly proportional to R. What is G? G is directly proportional to R, and we know very well here the ratio also. Is it? So see, hence the gravity on the planet and the gravity on the earth, what is given here? We can write here, see, Rp by Re. And what is Rp by Re? We have got here 2 power 1 by 3. How much here? 2 power 1 by 3. So now if I just multiply with the mass here mass and here mass. Okay. So in this situation, this thing can be written as weight on the planet by weight on the earth. What is coming? 2 power 1 by 3. Is it? And weight on the earth, what they are giving here? W here. Now you can see that giving here W. Is it? So we can write here now the weight on the planet is going to be 2 power 1 by 3 into W. Is it? So which option is correct here? The correct option is here option A. So students, in this question, why this question was different? Because they told mass also, they told density also. So what we have done? First, with the help of density and mass, we have got the ratio of the radius, because radius ratio is not known. And then as the density was constant, I have used this formula and very easily I have got the answer. Cut. Is it? So students, I hope so. This question is very clear to you, and this full video is also very clear to you. Keep studying, keep growing.